All right, so in this video, we're going to talk about period, which is the sine and cosine version of horizontal stretching and compressing. Okay, you can see we have coefficients inside the function, inside of our sine function, and so it does just what it did with other functions. This is actually going to be a horizontal compression, this 3 in here, and this is going to be a horizontal stretch. But what we talk about is we talk about it in terms of the period instead. So we talk about it as, is the period longer or is the period shorter? Okay. In this case, it's going to be 3 times faster. In this case, it's going to be 3 times slower, so that makes it a longer period. Stretches it out. So we're going to go back to this graph over here, and it's just good practicing, again, setting up a graph with fractions of pi. This time I'm going to do it a little bit differently because I know that I'm going to have this sine of 3x, okay? And so if my period is normally 2 pi, and I know that now it's going to be 3 times shorter, that means that my period's actually going to be 2/3 pi. It's going to be 2/3. And so I'm actually going to use, I think I want to use pi over 12 as my scale. It's going to be tough because I'm dealing with this graph, and then we're also dealing with y equals sine of 1/3 x, which this has a period of 6 pi because it's 3 times longer. And so we're probably not going to fit all of this graph on here, and this graph is, if we wanted to fill the entire graph with this function, we would have to use pi over 12 as our unit. So I'm actually going to, I think I'm going to settle on pi over 6 as every other one. So if this is pi over 12, then 2 pi over 12 is pi over 6. So we can think of this pi over 12 as our individual unit, but I'm just going to label every other one using fractions of pi over 6. So pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And then 5 pi over 6 is 5 pi over 6. And then 6 pi over 6 gives me pi. And then we have 7 pi over 6. And we have 8 pi over 6, which is 4 pi over 3. Okay, and that's as far as we can get in that direction. And we'll do the same thing in this direction. So we have negative pi over 6, negative pi over 3, negative 3 pi over 6, which is negative pi over 2, negative 4 pi over 6, which is negative 2 pi over 3, negative 5 pi over 6, negative 6 pi over 6, negative 7 pi over 6, and negative 8 pi over 6. And again, it's just good practice to be counting in fractions of pi. Now, the amplitude for all 3 of these functions is not changed. It is 1. So I'm going to go up, I'm going to make 3 boxes in the vertical direction because I want to fill up as much of the graph as I can. So let's start with sine of x. Okay, so 0, 0 is there. And then pi over 2 is where we equal 1. And then pi is 0. And then 3 pi over 2, which is actually out here, would be where I would equal negative 1. So you can see that even sine of x with this new scale that we decided on doesn't quite fit. But I can still fit a whole cycle. I just have to do it going into the negative direction. So I can also go back. So negative pi over 2 is here. And then negative pi is here. And then again, I don't quite get to where I wanted to for this value. But you can still, I still got an entire period in there, which is called a cycle. I got that in there. It starts here at negative pi and goes to pi. There's my 2 pi period. So I do have an entire period on there. And that's the important thing. So now let's try sine of 3x. We're going to do this in red. And now, in the last one, when we did the amplitude, all of our key points, the horizontal locations of them, didn't change at all. But this one's going to change. So normally, to get from 0 to my next point, I went over 1, 2, 3, 4, 5, 6 boxes. Now this is saying cut that in 3, cut that by 3. So I'm going to go over 2 boxes. So pi over 6 is going to be where I actually hit this first key point. And then pi over 3 is where I go back to 0. And then pi over 2 is where I get to -1. And then 2 pi over 3, which is what I originally said the period was going to be for this function, is where this one ends. And so, let me try that again. So my sine function is compressed horizontally. But I think the better way to think about this is that the period just happened 3 times faster. And this can keep going. I can keep plotting this if I wanted to in both directions. And once you know the pattern, it's just really easy to follow. In this case, it's every basically I made the scale for this particular function, and so it's every box that I've labeled is a key point. And there we go. So there's my sine of 3x. And finally in green, we're going to do our sine of 1/3 x. Now, if I'm normally supposed to go over 1, 2, 3, 4, 5, 6 boxes, that means I would have to go over 18 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I didn't even quite make it. This would be right here, would be where my first key point is, would be off the graph. And so it's actually going to be way over here, okay? Actually shouldn't go past 1 until I get there. I should hit 1. And then down here is where it would hit -1. So awful. So you can see the green graph is incredibly stretched, okay? Which makes sense because it has a period of 6 pi instead. All right, so in the next video, we're going to talk about phase shift and we'll do one example where we have both an amplitude and a period change. We'll talk about phase shift, and then we'll put it all together in the last video. All right, I'll see you.